Hello teacher, I'm Tilis Bergendos. I'm from group SC 2414. I have an assignment for the third chapter and the third section, assignment 5 and 12. Assignment 5, part A. I will prove that a function g of m and n is equal to a function m and f of n, where g is one-to-one and onto. Let's get started. First, I will prove that it's one-to-one. Suppose a function g of m1 and n1 is equal to function g of m2 and n2. Then this implies a function m1 and f of n1 is equal to a function m2 and f of n2. Then m1 is equal to m2 and function f of n1 is equal to a function f of n2. Since f is given to be one-to-one, function f of n1 is equal to function of n2 implies n1 is equal to n2. Therefore, m1 and n1 is equal to m2 and n2. It's proving g is one-to-one. Second, I will prove that it's onto. Let m and z belongs n to z. We need to find m prime and n prime belongs n to n, such that function g of m prime and n prime is equal to m and z. Set m prime is equal to m and let n prime belongs n. Satisfy function f of n prime is equal to z, such n prime exists because f is onto. Then g of m prime and n prime is equal to m and f of n prime is equal to m and z. Answer: thus g is both one-to-one and onto. Assignment 5, part B. To find a one-to-one correspondence between n to n and n to z, we leverage the bijectivity of f and define a function h. A function h of m and n is equal to function m and f of n. First, I will prove that its injectivity. Suppose a function h of m1 and n1 is equal to a function h of m2 and n2. Then m1 and f of n1 is equal to m2 and f of n2. From equality of ordered pairs, m1 is equal to m2 and function f of n1 is equal to a function f and of n2. Since f is injective, n1 is equal to n2, so m1 and n1 is equal to m2 and n2. Thus h is injective. Second, I will prove that it's surjective. Let m and z belongs n to z. We need m prime and n prime belongs n to n, such that h of m prime and n prime is equal to m and z. take m prime n is equal to m and n prime belongs n, satisfying a function f of n prime is equal to z exists because f is surjective. Then h of m prime and n prime is equal to m and f of n prime is equal to m and z. Thus, h is one-to-one correspondence between n to n and n to z. Assignment 12, Part A. I will prove that intervals 0, 1 and 1, 2 have the same. To show that these two intervals have the same cardinality, we construct a bijection, a one-to-one and onto function between them. Let function f maps 0, 1 to 1, 2 be defined as a function f of x is equal to 1 plus x. Proof: if a function f of x1 is equal to a function f of x2, then 1 plus x1 is equal to 1 plus x2. Therefore, x1 is equal to x2. Thus, f is injective. For any y belongs 1, 2, we can solve for x in f of x is equal to y. Then x is equal to y minus 1. Since y belongs 1, 2, y minus 1 belongs 0, 1, thus every y belongs 1, 2 has a preimage in 0, 1, so f is surjective. Since f is both injective and surjective, it's a bijection. Therefore, the intervals 0, 1 and 1, 2 have the same cardinality. Part 2. I will prove that the intervals 0, 1 and 4, 6 have the same cardinality. We use the same strategy to construct a bijection. Let a function g. G maps the intervals 0, 1 to the intervals 4, 6 be defined as a function g of x is equal to 4 plus 2x. Proof: if a function g of x1 is equal to g of x2, then 4 plus 2x1 is equal to 4 plus 2x2. Therefore, x1 is equal to x2. Thus, g is injective. For any y belongs the intervals 4, 6, we solve for x in a function g of x equal y. Then x is equal to y minus 4 divided 2. Since y belongs the intervals 4, 6, y minus 4 divided 2 belongs 0, 1. Thus every y belongs the intervals 4 and 6 has a preimage in the intervals 0, 1. So g is surjective. Since g is a bijection, the intervals 0, 1 and 4, 6 have the same cardinality. I will prove that any two open intervals a and b and c and d have the same cardinality. To prove this, we construct a general bijection for arbitrary intervals a and b and c and d. Let a function h maps the intervals a and b to the intervals c and d be defined as a function h of x is equal to c plus the quantity d minus c times x minus a divided by b minus a. Proof: if a function h of x1 is equal to a function h of x2, then c plus the quantity d minus c times x1 minus a divided by b minus a is equal to c plus the quantity d minus c times x2 minus a divided by b minus a. Subtract c from both sides and divide by the quantity d minus c divided by b minus a. Then x1 minus a is equal to x2 minus a. Therefore, x1 is equal to x2. Thus, a function h is injective. For any y belongs c and d, solve for x in a function h of x is equal to y. Y is equal to c plus the quantity d minus c times x minus a divided by b minus a. Therefore, x is equal to a plus the quantity b minus c times y minus c divided by d minus c. Since y belongs c and d, x belongs a and b, thus h is surjective. And since he is both injective and surjective, it's a bijection. Therefore, any two open intervals a and b and c and d have the same cardinality.